All right, so we did this one in class, but let's just start from there so that it's good, solid. Make sure we have everything filled out together and finish up this packet. So let's talk about the telescoping series. So if you notice there's a subtraction sign in your series, then a lot of times it's going to be telescoping. So let's just write out a few and see. And I always recommend when you're doing a series just to write out a few and see what you see. Okay. So if you put in 1, you get 1 minus a half plus, all right, now put in 2. A half minus a third plus, now put in 3. A third minus a fourth. It is. Okay, but you always, so the 1's definitely there. And then whatever this is. So the series is going to, I'm just going to put a star here. It sums to the limit as n goes to infinity of 1, because that's the first one. And then it's always going to be minus whatever here. So minus 1 over n plus 1. Well, that goes to 0, so we just get 1. Okay. All right, so that's it. All right. Let's do the next one. All right. This one, we can do 2 ways. Let's write out a few first. Okay. So S1. So I'm going to put a line down the middle here. Well, that was terrible, but whatever. Okay, and the first one, we're just going to do the summation, the partial summations, things like we've been doing. So S1. Okay, S1 is what? So you plug in 1 and you get 2 over 3. So then S2, okay, is 2/3 plus, now plug in 2. So that's 4, 16, 15, so 2/15. And then use your calculator to add those. That's what, 10, 12, 12/15. I like to write it every way possible. So like this, and then also reducing it so that we can see like whatever pattern might emerge. Sometimes it emerges with a non-reduced, sometimes it emerges with the reduced. So that gives me 4/5. All right. And then S3 is what? 4/5 plus, now plug in 3. 2 over 3 is 9 times 4 minus 1 is 35. 9 times 4 is 36. Yeah, 35. And then what is that? Times 7. So 30. 29, 30. 35ths. Okay, which reduces by 5, 6, 7ths. Okay. All right. I think I see a pattern with the reduced one. See? 2, 4, 6, 3, 5, 7. So I think I can do n is 1, 2, 3. And Sn is what? 2/3, 4/5, 6/7. So Sn as a sequence would be what? 2n, right? Even, that's how we say even. Over odds, but you got to make sure you go the right way. So 2n plus 1, because this is 1 bigger than that one. See, 5, 4, 7, 6. So 2n plus 1. Okay, I'm just going to put a star up here. So star equals the limit as n goes to infinity of 2n over 2n plus 1, which that's a ratio of 1 to 1, because, well, 2 to 2, so 1. Okay, all right. Now, this is the way that the book wants you to do it, is the way I'm getting ready to do it, but I think it's silly. I like the partial sums better. So this is the way I did it. Okay, but let's do it the other way. So it's under the telescoping part. So, and there's a minus sign. And I said, careful, if you see minus signs, think about telescoping and see if it is. So I'm going to first just factor this. So 2 over 4n squared minus 1 is 2 over 2n plus 1 and 2n minus 1. Now, those differ. Well, they differ by 2, though. So, but a lot of times if they differ by like 1, or if they're like a sum of squares, I mean a difference of squares, then it's going to be telescoping. Okay, so now we're going to do partial fractions. So 2 over 2n plus 1 times 2n minus 1. has to equal, do you remember how to do that? A over 2n plus 1 plus b over 2n minus 1. Okay, so then that's 2 equals a 2n minus 1 plus b 2n plus 1. I highly recommend you pause it and work it out and see if you get the right partial fractions right here. And then see if you get it. Okay, all right, so then now I get 2 equals 2an minus a plus 2bn plus b. Okay, so in 2, there are, so n's, there's 0. So that would be equals 2a plus 2b. And then constants, there are 2, equals negative a plus b. All right, I'm just going to multiply everything by 2. So I get 0 equals 2a plus 2b, and then 4 equals negative 2a plus 2b. So 4 equals 4b, so b equals 1. And if b is 1, then 2 equals negative a plus 1. Subtract 1, 1 equals negative a, so a equals negative 1. All right, so now star equals the sum from n equals 1 to infinity. I hate that they changed it to ends. I just got to throw that in there again. Like, why didn't we leave it as? Now we have ends, but we used ends at the top of 4. I think it's because this is going to infinity, and that's what our ends were going to up top of 4. But anyway, side note, continue. So then now we get a is that. So negative 1 over 2n plus 1 plus 1 over 2n minus 1. Okay. So let's switcheroo them so that, so n equals 1 to infinity of 1 over 2n minus 1 minus 1 over 2n plus 1. Okay, now let's write out a few. So 1, we get 1 over 1 minus 1 over 3 plus, now plug in 2, so that's 4 minus, so a third minus, now plug in 2 here, and that's 5, plus, see, and look at that, those cancel. Now plug in 3, that's 6, yeah, a fifth, minus, now plug in 3, and that's 7. See, it's just odd, like 1 over the left odd minus 1 over the right odd. See, these are both odds. This is the lesser odd, this is the greater odd, right? So it is telescoping. Okay, which equals, so that equals, well, the first number. So the limit, as n goes to infinity, of 1 minus 1 over 2n plus 1, which that goes to 0, so we get 1. Telescoping series do not always go to 1. I hate that both of those examples went to 1, but these were the same example. This was the telescoping way, which was pretty convoluted. This was the partial sums way. Okay? All right, moving on. Okay, this is what I was trying to do before with that 1 over, like that 0.11111. The problem was that our series had started with 1 instead of 0. Okay, so geometric series. The series given in a previous example of n equals 1 to infinity of 1 over 2 to the n is a geometric series. In general, the series given by this is a geometric series with ratio r. If it's greater than 1, then it diverges, okay? And if it's between 0 and 1, then it converges to this actual sum. Okay, so now it's time to pull out that sheet. Right there. There it is. Ooh, sorry for the bouncing. Lost my grip there. Okay, this should be for n equals 0 to infinity. So you should write that in there. Okay, so it converges, diverges, and then that. Okay, so before we had n equals 1 to a ninth, so we need to take 1 off of it because that made my sum 1 too big. Okay, because that would have been 1.11111 if I had started with n equals 1. Okay? I mean, within equals 1. Okay? So that was the issue with that one way back in our notes earlier. All right. But anyway, so, and on here, let's just put a little dot right here because that means we've covered it. So you know everything we've gone over. Okay, so discuss the series convergence or divergence. So it does not say find the sum. Generally, they're going to say find sum if possible, which most of them are, you're not going to be expected to find the sum. You're just going to be expected to discuss the convergence or divergence. But I'm going to add the find the sum because we're under geometrics and we can actually find the sum. Okay? Notice that's only 2 of them. It's the which we've also discussed. The telescoping series, right? That's the sum right there, B1 minus L, where the L is the limit as you go to infinity. So we've definitely done that. And that's about the only ones we can find the sum of, see? Unless you do partial sums. Okay, so you can always find the sum by doing that S1, S2, S3, and finding a formula, and then letting it go to infinity. All right, so discuss the convergence or divergence. Well, first of all, here, let's take the 3 out. So this is 3 times the sum of n equals 0 to infinity of 1 over 2 to the n. Now you can write it like that, see? Because 1 to the n is 1, and 2 to the n, that's on the bottom. And the 3 was not messed with, so there we go. Now this right here is a geometric series. With absolute value to r equal to 1/2, which is less than 1, okay? Therefore, it converges, right? Because that's what this says, to 1 over 1 minus r. Which is 1 over 1 minus 1/2 is 1 over 1/2, which is 2, okay? All right, so the whole thing equals 3 times 2, which is 6. All right, this is a geometric series with absolute value of r equal to 3/2, which is greater than 1, so it diverges. Okay? The formula for the sum of the geometric series can be used to write a repeating decimal as a ratio of 2 integers. Okay? All right, this is what I was talking about before that we had started with the 0.999. I mean, 0.11111. All right? But now we actually have to, but let's do it with the correct way with n equal to 0, and then our summation formula should work out just fine. Okay, so let's write this. So 0.08. First of all, I taught you that pattern, which was you take how many of them there are. So this should be our answer, is 8 over, and then that's how many 9s you put. So there are 2 numbers, so 99. It would be 08 over 99, but we write it as 8 over 99. So that should be what we come out as the answer. That's the trick I taught you. Okay, so everybody follow that. So there are 2 numbers that repeat, so you do 2 9s in the bottom, and then you just write the 2 numbers on top. Okay? All right, so this is what? So 0.08 repeating is 0.08 plus 0.0008, right? That's these 2. Plus 0.000008, right? If you stick these in there and there, that works. Yeah? Okay, so this is 8 tenths hundredths plus 8 tenths hundredths thousandths 10 thousandths plus 8 tenths hundredths thousandths 10 thousandths 100 thousandths millionths. Or in other words, just count it. 1, 2, 3, 4, 5, 6. 6 zeros. All right, which equals what? 8 over 10 squared plus 8 over 10 to the 4th plus 8 over 10 to the 6th. Okay, and then I think we got it. I think I can see the pattern. That equals the sum, and you got to start with 0 if you're going to do geometric. 0 of 8 over 10 to the something. Now be careful. So this is 0. This is 1. This is 2. Okay, so 0. These are even, so we know it's going to be like 2n plus 1 or 2n minus 1. Oh, no, sorry, even. 2n. Okay. All right, so let's try that. 0, no, that wouldn't give it. 1 would give you 2. 2 would give you 4, so we're 2 off. So that's how you would get to the next even number if you want to go bigger. So let's try that. 0 would give you 2. 1 would give you 4. 2 would give you 6. Yeah, that's it. So 2n plus 2. Okay, now that does not look geometric, but we got to pull out the stuff that's not relevant. So this is the sum of n equals 0 to infinity of 8 over 10 to the 2n times 10 squared. Okay, those can come out because they don't have n's. Oops, I forgot to bring them out. After I just said that. 8 100ths, right? And then 1 over 100 to the n? Does that work? Yeah, because that's 10 squared to the n. Okay? Is into the 2n. That's 2n. See? Okay, so that is 8 100ths. N equals 0 to infinity of 1 100ths to the n. And there we go. That sum is 1 over 1 minus 1 100th. Okay, because it's less than 1. So then 1 over 1 minus 100th is 1 over, what? That would be 100 minus 1, so 99 hundredths. Okay, which is 100 over 99. Okay, that's just that part. So now the whole thing, I'm just going to put a big old star right here. Okay. Not here because that goes to here. So then that equals, I'm just going to bring it back here, 8 over 100 times 100 over 99, which is 8/99. Woo! I like the trick better, but the reason why the trick works is because of this, because you're doing 1 minus 100th and like all the time for these, because they're factors of 10. Okay, so it's not so much a trick. It's just that before the series part, it's a little bit harder to prove. You can actually prove it even in Algebra 2, but by like adding an x and then taking off an x. Okay, all right, but we don't have time to show that right now. We're already at 19 minutes. All right, continuing on. So we found earlier that this was 2. Use this knowledge to evaluate 1. Oh, so from n equals 4. Okay, so you got to shift it by 4. Okay, so what does that mean? Well, that means that 2 equals the sum of n equals 0 to 3 of 1/2 to the n plus the sum of n equals 4 to infinity. See, this is just 0, 1, 2, 3, and then this is 4, 5, 6, 7, and blah, blah, blah. Right? Okay, well, we can easily figure this out because that is a finite number. So that would be 1 plus, now plug in 1, a half, plug in 2, we get a fourth, plug in 3, we get an eighth. That's all of that. Plus the sum of n equals 4 to infinity of 1/2 to the n. So add all that up, you get something, let's see, that's 4, 5, 6, 7. So that would be 1 7/8. Okay? And then take off that, so that'd be, take off 1, and we get 1 minus 7/8 will be an eighth. Okay? Okay. We've already actually used this property, so like if this sum is A, then this would be CA. And here this would just be A plus B. Like you can sum them individually, just like we just did here. We can also pull things out that don't have n to do with them, so on and so forth. Okay. The limit of the nth term test of convergence series. If the series converges, then the sequence converges, just the sequence. See? Okay, not the... Okay, just like this dude by itself. Okay, this is not very helpful. It's actually more helpful to use it the other way, okay? If the sequence diverges, or no, not diverges, sorry, doesn't go to 0, then the series diverges, okay? So, and this makes sense if you think about it. If you've got a sequence and you're building up, okay, so let's think of the series as sand, like a vase that we're filling with sand, and this is telling us how much sand, the sequence part is telling you how much sand to put in each time. If you're getting bigger and bigger, you're putting more and more sand in the vase, then the vase is going to overflow. You're not going to get like a finite number. But if you're putting less and less and less sand in each go, like it doesn't matter if you put 1,000,000 pieces in the first go, if you're going to get less and then less and then less, then there's a chance that this converges, okay? It doesn't mean that it does converge, okay, but there's a chance that it does. If this doesn't go to 0, you're just putting more and more sand in and it's going to overflow. So this one definitely can't converge, okay? All right, so the same idea here. So the sequence doesn't go to 0, then the series diverges. That's super useful, okay? All right, and this is called the nth term test. We're going to definitely use that a lot, okay? And it's on here, the nth term test. Diverges if the sequence doesn't go to 0. This test cannot be used to show convergence, just divergence. Okay? All right, so looking at this one, the limit as n goes to infinity of 2 to the n is infinity, which is not 0, so this diverges. Okay? All right, the next one. Okay, what does that go to? Well, I know that we don't really have like a L'Hopital's or anything for that, but the limit as n goes to infinity of n factorial over 2n factorial plus 1. I want you to think about that. That's like an exponential or any kind of same ratio. The ones fall off in the end, so we just get the same thing basically, and those would cancel, and you'd get a half, which is not 0. So this diverges. Okay, all right, 1 over n, the limit of 1 over n as n goes to infinity is 0. So this tells you nothing. So may all your sequences not go to 0. Okay, so how do we do that? Well, if you don't know how to do it, well, we haven't learned this one. This one's called a harmonic or a p-series, okay? But if you can't, but we haven't learned that yet, so what do? All we know is geometric. Nth term test failed us. It's not geometric because that has to be one, like a number to the n, not 1 over n. And it's not telescoping because it doesn't even have 2 parts to it. So all we can do is s's. So S1 is 1. S2 is 1 plus a half, which is 3 halves. S3 is 3 halves plus what? 1/3, which is 11/6. S4 is 11/6 plus 1/4, which is 25/12. I don't know. All right. So at the moment, we're just going to say that we can't say either way. If you find a sequence, if you find an SN, let me know. Email it to me. Bonus points. Okay? But I'm just going to say, can't say for now. Okay? Oh, well, that's the end of it. So actually, let's go ahead and say it. Let's look at the p-series thing. Let's see if you can figure it out that way. 1 over n, p would have to be what? It would have to be 1. And with p equals 1, it diverges. So you say it's a p-series with p equals 1, which diverges. Okay? All right, and we sort of went over this. I'm going to go ahead and put a dot because it's really just reading a chart. Okay, and that is it.